DNS is not optional. In production, many incidents that first look like application failure or network failure are actually DNS problems. The workload may be healthy and the root may exist. But if the name resolves to the wrong place, the service still feels down to the user. Think about one public name like api.company.com and one private name like payments.internal.company.local. They solve different jobs and should not be treated as the same kind of record. And then the hybrid problem starts. AWS may need an on-premises database name, and on-premises users may need an AWS private service name. That is where Route 53 resolver, endpoints, and forwarding rules become production basics. By the end of this tutorial, you should know what public hosted zones do, what private hosted zones do, what Route 53 resolver does by default, and when hybrid DNS needs explicit resolver endpoints. We will use one realistic architecture all the way through. A company with a public API, private payment services, and systems that still live on premises. The mental rule for this topic is simple. A hosted zone stores records. A resolver answers questions. Keep those two jobs separate in your head, and AWS DNS becomes easier to reason about. I also want to give you the production version of the lesson, not just the dictionary version. So we will cover split horizon DNS, forwarding rules, hybrid resolution, and the design mistakes that cause real incidents. A Route 53 public hosted zone stores records that should be resolvable from the public internet. If api.company.com points to a public ALB, that public record belongs there. A Route 53 private hosted zone stores records that should resolve only inside the VPCs associated with that zone. If payments.internal.company.local points to an internal ALB, that private record belongs here. Route 53 resolver is available by default in your VPCs. It resolves public names, AWS and VPC specific names, and private hosted zone records that are associated with the querying VPC. For hybrid environments, you add inbound resolver endpoints, so on-premises DNS can ask AWS about private names, outbound resolver endpoints, so AWS can ask on-premises DNS about corporate names, and forwarding rules that decide which suffix goes where. Now build the public side. An internet user asks for api.company.com, public DNS follows the Route 53 record, and the answer points to a public application load balancer. Now build the private side. A workload inside the VPC asks for payments. Internal.company.local, Route 53. Resolver checks the associated private hosted zone, and the answer points to an internal ALB. The key design step is association and scope. Private hosted zones only answer for the VPCs that are explicitly associated with them. Now add split horizon DNS. The same logical service name can return one answer outside AWS and a different answer inside selected VPCs. Trace the public query first. A user device asks its normal DNS resolver for api.company.com. The public DNS path reaches Route 53 and the public ALB answer comes back. Now trace the private query. An EC2 instance, ECS task, or EKS pod asks Route 53. Resolver for payments.internal.company.local, and the resolver returns the internal ALB answer from the private hosted zone. Now trace AWS to on-premises resolution. If an app in AWS needs db.corp.company.local, a forwarding rule matches that suffix and sends the query out through an outbound resolver endpoint to corporate DNS. Finally, trace on-premises to AWS private resolution. An on-premises application asks for payments.internal.company.local. Its DNS server forwards that suffix to an inbound resolver endpoint in AWS, and the private zone answer comes back. This is where many teams get caught. The network path may be fine, but the query path is broken. A missing forwarding rule can make a healthy hybrid link look like an outage. Resolver endpoints also need real infrastructure support. They need subnet placement, IP addresses, security groups, and working DNS traffic over UDP and TCP port 53 where the design requires it. Another common problem is namespace confusion. Overlapping private namespaces, forwarding loops, and careless split horizon design can make one name behave differently in ways the team can no longer explain during an outage. And remember this rule: DNS resolution is not the same thing as connectivity. A name can resolve correctly while routing. Security groups, firewalls, or load balancer policy still block the real connection. The better production pattern is explicit DNS ownership. Public names stay in public zones, AWS only, private names stay in private zones, and on-premises corporate names stay owned by on-premises DNS. For on-premises to AWS private resolution, let the on-premises resolvers forward only the AWS private suffixes they need to an inbound Route 53 resolver endpoint. For AWS to on-premises resolution, let AWS workloads use forwarding rules that send only approved corporate suffixes through an outbound Route 53 resolver endpoint to on-premises DNS. Then add production discipline around the whole design. Log DNS queries, document suffix ownership, test failover, and make sure the team can trace one name from source system to final answer without guessing. So keep this mental model. Public hosted zones answer public names. Private hosted zones answer VPC scoped private names. Route 53 resolver is the default DNS engine inside the VPC. Resolver endpoints and forwarding rules are what make hybrid DNS work across AWS and on-premises boundaries. If you are designing DNS in AWS, ask 4 questions first. Is the name public or private? Which VPCs should resolve it? Does the suffix need to cross AWS and on-premises boundaries? And after resolution, is the real network path allowed? A very practical next step is to pick one real application and trace the exact DNS name, the zone that owns it, the resolver that answers it, and the network path that carries the connection after resolution.